Okay, next one, a short trick for stereochemistry. Based on this short trick, you can predict the stereochemistry of any electrocyclic reaction. It is very useful for your NET and GATE exam. Okay, suppose you have the conjugated diene or polyene like this. One of the substituent is in the below direction, other substituent is just opposite to that. One substituent is below, the next substituent is opposite to that. So the two substituents are in opposite direction. Two substituents are in opposite direction. Okay. Then another possibility, you have the reactant. Okay. One substituent in the upward direction, other substituent in the downward direction. Here also the two substituents are in opposite direction. Okay, one is in the upward direction, other is in the downward direction. Here also these two are in opposite direction. Then another possibility, okay, one in the downward direction, then other is also in the downward direction. Here this substituent in the downward direction, this also in the downward direction. The two substituents are in same direction. Okay, then another possibility, here this substituent in the upward direction, this substituent is also in the upward direction. This substituent is also in the upward direction. Okay, this is in the upward direction, this is also in the upward direction. That means both substituents are same. So two categories are there, both substituents in opposite direction, both substituents in same direction. Clear? You have to predict the stereochemistry of these two methyl group, these two methyl group, these two methyl group, these two methyl group. Okay, if methyl and methyl are in opposite direction, methyl and methyl are in opposite direction, one below, one above. One below, other is also below. One above, other is also above. These two are same, these two are opposite. Or we can also find this by, what is the stereochemistry of this alkene? This alkene is an E alkene. E alkene. This alkene is also an E alkene. Okay. This alkene is an Z alkene. This alkene is an Z alkene. This alkene is Z. This alkene is E. This alkene is E. This alkene is Z. What is E and Z alkene? What is E and Z alkene? That detail we will study in stereochemistry. Suppose an alkene, this is a double bond. Here two methyl substituent, here hydrogen. Okay. So methyl group having higher priority. Instead of cis and trans, we use E and Z. Okay. Methyl group having higher priority, hydrogen having second priority. Same prior group on same side, this is called Z. Z means same prior group on same side. So this is an Z alkene. Then another alkene, a double bond. Here methyl group, here methyl, here H, here H. This is an example for same prior group on opposite side. This is called E alkene. So two types of alkenes are there, E alkene and Z alkene. E alkene and Z alkene. Okay, E alkene means same prior group on same side. Same prior group on same side Z. Same prior group on hydrogen and hydrogen, opposite. Methyl and methyl, opposite. That is E. Same prior, methyl and methyl, same. Hydrogen and hydrogen, same. That is Z. That is called E and Z alkene. Okay. Whether this alkene is E alkene or Z alkene. Whether this alkene is E alkene or Z alkene. Here there are two carbon atoms, carbon 1 and carbon 2. At the carbon 1 2 group, methyl and ethyl. Ethyl having first priority, methyl having second priority. In carbon 2 group, methyl and hydrogen. Methyl having first priority, hydrogen having second priority. So same prior group on opposite side. So this is an E alkene. This is an example of E alkene. Clear? 1 second. 1, 2. 1, 2. Same prior group on same side. That is an Z alkene. Sorry. Z, same prior group on same side. That is an Z alkene. Then what about this alkene? What about this alkene? Whether this is E or Z? Here two carbon atoms are there, carbon 1 and carbon 2. In carbon 1, ethyl group and ethyl group. Sorry, 1 second. Okay. In carbon 1, CH2, CH3, ethyl group and propyl group. Propyl group having first priority, ethyl group having second priority. In carbon 2, hydrogen and propyl group having first priority, hydrogen having second priority. Same priority on opposite side. So this is E alkene. Okay. We will study E and Z alkene in stereochemistry. Okay. Same prior group on same side, that is Z. Same prior group on opposite side, that is called E. Okay. So this alkene, same prior group on opposite side E. Here same prior group on same side is Z. Same prior group on same side is Z. Same prior group on opposite side E. Same prior group on same side is Z. Same prior group on same side is Z. Same prior group on opposite side E. Okay. If your alkene is an EE alkene or Z alkene, that means opposite. If your alkene is an EZ alkene or an EZ alkene or an ZE alkene, that means same. So for category of alkenes that I discussed, the opposite alkene and opposite substituents are opposite, substituents are same. Whenever EE or ZZ, substituents are opposite. Whenever EZ or ZE, substituents are same. Okay, so going to our rule. Direction of substituent. Direction of substituent. Rotation. Direction of substituent. Rotation and stereo. Direction of substituent, rotation and stereo. Okay. So this rule is also called as OC. 1 second. This rule is also called as ODC rule. This rule is also called as ODC rule. Okay, ODC rule. When substituents are opposite, rotation is dis. Then the stereochemistry is cis. That is called ODC rule. Okay, substituents are opposite direction. You are performing disrotation. Then stereochemistry is cis. Then if substituents are opposite direction, you are performing con rotation, then it will be trans. Just opposite. You have to remember only one, then you can write all other thing. Okay, just ODC rule. Substituents are opposite, you are performing disrotation, stereo is cis. Then substituents are opposite, then you perform con rotation, then stereo is trans. So compare with this. Substituents are same. You have to compare with the first one. Substituents are same, then disrotation, same disrotation, instead of cis here trans. Then substituents are same, con rotation, cis. Okay, so remember two things. ODC and SCC. Okay, ODC and SCC. Okay, that you can predict the stereochemistry of any reaction. If substituents are in opposite direction, stereochemistry is, and you are performing this rotation, stereochemistry is cis. If substituents are in opposite direction and you are performing con rotation, stereochemistry is trans. Substituents are same direction, disrotation, then trans. Substituents are in same direction, then con rotation, then cis. ODC, SCC. These two things when you remember, you can work out any problem based on electrocyclic reaction, based on the stereochemistry. Okay, moving to some question. First question. Condition is thermal. Write the product. Condition is thermal. So here this is a conjugated diene, definitely electrocyclic reaction. So a 4-membered ring is formed. Okay, 4-membered ring is formed. Here there is a double bond. Okay, so here two substituents are there. What is the stereochemistry of these two substituents? You have to put the ODC rule. What is the system here? System is foreign. System is foreign. Condition is thermal. That is given in the question. Foreign thermal, what type of rotation that you have to perform? Con rotation. You have to perform con rotation. Then what about the substituent? One below, one above. Substituents are in opposite direction. So you can prefer the ODC rule. ODC. Substituents opposite. Yes, substituents are opposite. Whether disrotation? No, it is con rotation. So take the next one, OCT. If you know ODC, opposite discon, then opposite con trans. So you have to follow OCT rule. Substituents are opposite. Con rotation, definitely stereochemistry is trans. Okay, substituents are opposite. Con rotation, definitely the stereochemistry of these two methyl group is trans. First methyl group above the plane and second methyl group below the plane. Okay, OCT. Clear? Clear? Okay. Second question. Photochemical condition. Condition is photochemical. What is the system here? System is a foreign system. Condition is photochemical. Okay. Foreign system. Condition is photochemical. And condition photochemical means disrotation. Condition photochemical means disrotation. In the previous problem, con rotation is there. Okay. So foreign photochemical, foreign thermal con, foreign photochemical disrotation. Okay. What about the substituents? One below, one above. Both are in opposite direction. Substituents are in opposite direction. Okay. So substituents opposite, disrotation. You can follow ODC rule. Substituents opposite, rotation is dis. Definitely stereochemistry is cis. Stereochemistry is cis. So what is the product? Pi bond shift here. This pi bond shift here. So you will get a 4-membered ring. 4-membered ring like this. What about the stereochemistry? Stereochemistry of these two methyl groups is cis. Stereochemistry of these two methyl groups is cis. Both are in same direction. Okay. Okay, then third question. Third question. One above, other below. Thermal condition. Thermal condition. Okay, substituents one above, other below. Substituents are in opposite direction. 2, 4, 6. 6 electrons are there. So system is 4n plus 2 thermal. 4n thermal con, 4n plus 2 thermal dis. Okay. 4n thermal cone. So 4n plus 2 thermal, what is the type of rotation? Disrotation. Disrotation. So you can follow the ODC rule. Substituents are opposite. Rotation is dis. So definitely stereochemistry is cis. Stereochemistry is cis. Before that, write the product. This pi electron shift here, this pi electron, this pi electron. So here between 1 and 6 a sigma bond is formed. A 6-membered ring is your product. This is first carbon and the sixth carbon. Between these two carbon, a pi bond is formed. Between these two carbon, a pi bond is formed. You have to predict the stereochemistry. Stereochemistry is what? Cis. Stereochemistry of that two methyl group is cis. That means both in the same plane, or above or below, both in the same plane. Okay, both in the same plane. Then what about the next question? Fourth one. First one above, second one also above. Okay, thermal condition. Condition is thermal. So here substituents, first one above, second one also above. So substituents are in same direction. 2, 4, 6, 4n plus 2 system. Condition thermal. 4n thermal cone. 4n thermal cone. Therefore 4n plus 2 thermal dis. 4n plus 2 thermal dis. Here substituents are same. Substituents are same. Follow the rule SCC. 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 Substituents are same. Cone rotation cis. But here the rotation is dis. So S rotation dis T. So you have to follow SDT. SDT. Remember ODC and SCC. Here SCC, but rotation is dis, therefore stereochemistry is trans. Therefore stereochemistry is trans. Then predict the product. Pi bond shifted towards here, towards here, towards here. So a 6-membered ring is your product. A 6-membered ring is your product. Here a new bond is formed between 1 and 6. Okay, then what is the stereochemistry? Stereochemistry is trans. One CH3 is above the plane and the other CH3 is below the plane. That is the stereochemistry. Okay. Okay, next question. One, 2, 3, 4, 5, 6, 7, an 8-membered ring. An 8-membered ring. Okay. Double, single, double, single, double, single, double. So here two substituents are there. One above, other below. One above, other below. Okay. Thermal condition. Condition is thermal. So write the product first. This pi electron shifted towards here, this towards here, this towards here. Here a sigma bond is formed between first and 8th carbon. So an 8-membered ring is formed. An 8-membered ring is your product. Okay, so between 1 and 8, a sigma bond is formed. This is 2, 3, 4, 5, 6, 7, 8. Okay, here between 2 and 3 a pi bond is formed. Between 4 and 5 a pi bond is formed. Between 6 and 7 a pi bond is formed. Between 1 and 8 a new sigma bond is formed. Okay, you have to predict the stereochemistry of these two methyl groups. So what is your system? Your system is 2, 4, 6, 8, 8 pi electrons. So system is 4n. Condition is thermal. So rotation is what? Cone rotation. What about the position of substituent? One above, other below. So substituents are in opposite direction. You have to follow the ODC rule. Here substituents are opposite, but rotation is cone, therefore trans. opposite dis is opposite con trans. So definitely stereochemistry of the two methyl group is trans to each other. So first one above the plane, second one below the plane. That is the stereochemistry of that two methyl groups. Okay. So next question. How many carbon atoms are there? 1, 2, 3, 4, 5, 6, 7, 8. One methyl group is above, other methyl group is also above. So the pi electron, okay, condition is thermal condition. You have to predict the product. First of all, you have to write the product. This pi electron shifted towards here, this towards here, this towards here. Here a sigma bond is formed. Between 1 and 8, a new sigma bond is formed. So the product is an 8-membered ring. Okay, this is first carbon number 1 and carbon number 8. Between 1 and 8, a new sigma bond is formed. 2, 3, 4, 5, 6, 7, 8. Okay. Between 2 and 3, a pi bond is formed. Between 4 and 5, a pi bond is formed. Between 6 and 7, a pi bond is formed. Okay, you have to predict the stereochemistry of these two methyl groups. So here one methyl group is above, the other is also above. So both are in same direction. When same direction, follow the rule SCC. Okay, follow the rule SCC. So 2, 4, 6, 8, foreign system, thermal condition, rotation is con, foreign thermal con. So same side con rotation, stereochemistry will be cis. That means the two methyl groups are in same, cis means same. One methyl group above, then other is also above. Or one methyl group below, the other is also below. That is the stereochemistry of that reaction. Okay, next question. Here a pi bond, here a pi bond, here a pi bond. Okay. Here a hydrogen is present. Here a hydrogen is present. Okay, two hydrogens are present. Condition thermal. You have to predict the stereochemistry of these two hydrogen. What is the product? This compound undergo electrocyclic reaction because conjugated polyene. This pi electron shifted towards here, this towards here. This will make a sigma bond here. This is carbon number 1, 2, 3, 4, 5, 6. So between 1 and 6, a sigma bond is formed. Between 1 and 6, a new sigma bond is formed. Between 1 and 6, this is 1 and 6, 2, 3, 4, 5, 6. So what about the position of double bond? Between 2 and 3, a double bond. Between 4 and 5, a new double bond. You have to predict the stereochemistry of these two hydrogen. One hydrogen is below, other hydrogen is above. Okay, one hydrogen is below, other hydrogen is above. That means they are in opposite direction. So system is 2, 4, 6, 4n plus 2 system. Condition thermal, definitely 4n thermal con, 4n plus 2 thermal dis. 4n plus 2 thermal dis. So follow the ODC rule. ODC. Substituents opposite disrotation, stereochemistry will be cis. So this hydrogen above the plane, this is hydrogen, then this hydrogen will be also above the plane. So the two hydrogens are on the same side. That is about the stereochemistry of this reaction. Okay. Then another question. Eighth one, double bond, single bond, double bond, single bond, double bond. Okay, here a methyl group is there, a methyl group, here a methyl group is there. Okay, condition photochemical. Find the product and predict the stereochemistry. Okay, what about the product? This pi electron shifted towards here, this towards here, this towards here. Here a sigma bond is formed. 1, 2, 3, 4, 5, 6. Between 1 and 6, a sigma bond is formed. So electrocyclic ring closure reaction, the product is like this. Between 1 and 6, a new sigma bond is formed. 2, 3, 4, 5. What about the position of double bond? Between 2 and 3, a pi bond. Between 4 and 5, a pi bond. Here a new sigma bond. What is the stereochemistry? One methyl group below, other methyl group above. That means the two substituents are in opposite direction. System is 2, 4, 6, 6 pi electrons. So 4n plus 2 system, 4n plus 2 system, condition photochemical. 4n thermal cone, 4n plus 2 photochemical cone. So you have substituents are opposite. So follow ODC rule. Substituents opposite dis rotation, but here rotation is cone. So ODC then OCT. Opposite dis cone then opposite cone trans. OCT. Substituents opposite, rotation cone, stereochemistry will be trans. That means the two methyl groups are trans to each other. First methyl group above the plane, then second methyl group below the plane. Second methyl group below the plane. That is about the stereochemistry of that reaction. Okay, moving to the next question. Question number 9. I think question number 9. Question number that. Here double bond, single bond, double bond, single bond, double bond. Okay. Here two hydrogens are there. This is the first hydrogen and this is the second hydrogen. You have to predict the stereochemistry of these two hydrogens. Okay. So condition is given. Condition is a thermal condition. Condition is thermal condition. Okay. You have to predict the stereochemistry of these two reactions. So whenever a question like this in your question paper and condition thermal, what type of reaction this compound will show? Electrocyclic reaction, because this is a conjugated polyene. So this pi electron shifted towards here, this towards here. This pi electron makes a sigma bond between these two carbon. So 1, 2, 3, 4, 5, 6. So between 1 and 6 a new sigma bond is formed. So the product is between 1 and 6 a new sigma bond is formed. So this is carbon number 1, 2, 3, 4, 5, 6. Between 1 and 6 a new sigma bond is formed. Between 2 and 3 a pi bond. Between 4 and 5 a pi bond. Okay, you have to predict the stereochemistry of these two hydrogens. First hydrogen is below, second hydrogen is above. That means the two hydrogens are in opposite direction. So system is a 4n plus 2 system because 6 pi electrons are there. 4n plus 2 thermal, 4n thermal cone, 4n plus 2 thermal dis. Okay, 4n thermal cone, therefore 4n plus 2 thermal is dis rotation. So you have to follow the ODC rule. ODC rule. Substituents are opposite, rotation is dis. So definitely stereochemistry will be cis. So what is the stereochemistry of these two hydrogen? Both are cis to each other. First hydrogen and the second hydrogen are in the same phase. Both above the plane or both below the plane. Okay. So that is the stereochemistry of that question. Okay. Now the 10th question. Fluorine, CH3, condition thermal. You have to predict the stereochemistry of this fluorine and CH3 both. So what is the reaction? Under thermal condition, electrocyclization takes place. So between these two carbon, between this 1, 2, 3, 4, between 1 and 4 carbon, a new sigma bond is formed. So you will get a 4-membered ring. Here a pi bond. Here a fluorine and CH3 is there. You have to find the stereochemistry. So we can compare, we can take a fluorine. These fluorine and these fluorine are in opposite direction because one fluorine below, other fluorine above. These fluorine are in opposite direction. System is 4n. So 4n thermal, the rotation is cone. 4n thermal rotation is cone. Then you can follow the ODC rule. ODC, opposite dis cis. But here rotation is cone. Therefore opposite cone trans. Opposite cone trans. Okay. Opposite cone trans. Opposite cone rotation. Then stereochemistry will be trans. That means these two fluorine are trans to each other. First fluorine above the plane, second fluorine below the plane. First fluorine above the plane, second fluorine below the plane. Then what is the stereochemistry of this CH3? What is the stereochemistry of this CH3? If fluorine is above, then CH3 is below. Here fluorine is below, then CH3 is above. So that is the stereochemistry of the product. Okay. Then 11th question. Same system, two fluorine in opposite direction. Here there is a CH3, here there is a CH3, but condition is photochemical condition. What is the stereochemistry? Condition is photochemical. What is the reaction? Electrocyclization. Between 1 and 4, a new sigma bond is formed. Between 1 and 4, a new sigma bond is formed. Okay. So you have to predict the stereochemistry. These two fluorines are in opposite direction. System is 4n. 4n photochemical, 4n thermal cone, 4n photochemical disrotation. So follow the ODC rule. Follow the ODC rule. Opposite. Fluorine and fluorine opposite. Rotation is dis. So definitely stereochemistry will be cis. That means the two fluorines are on same side. One fluorine above the plane. Then next fluorine is also above the plane. Then what is the stereochemistry of the CH3? If fluorine is above, then CH3 is below. If fluorine is above, then CH3 is below. That is the stereochemistry of that two CH3 groups. Okay. Then next question, 12th one. Typical system. Fluorine is above. Okay. CH3 is also above. Condition is thermal condition. What is the reaction here? Reaction here, electrocyclization. Pi bond shifted towards here. This pi bond makes a sigma bond. 1, 2, 3, 4. So between 1 and 4, a new sigma bond is formed and a 4-membered ring is formed. So here a pi bond. Then what is the stereochemistry of this fluorine and CH3? One fluorine above, CH3 is also above. So substituents are in same direction. So you have to follow the SCC rule. Then system is 4n. System is 4n thermal cone. 4n thermal cone. So your rotation is cone rotation. Then according to SCC rule, substituents the same side cone rotation, then they will be cis to each other. That means fluorine and CH3 are cis to each other. These two fluorine and CH3 are cis to each other. That is the stereochemistry of that fluorine and CH3. Okay, then next question. I think 14th question. Double bond, single bond. Here one hydrogen. Here one hydrogen. You have to find the condition is thermal condition. You have to predict the product and predict the stereochemistry of these two hydrogen. Predict the stereochemistry of these two hydrogen. Okay. What is the reaction? This pi electron shifted towards here, this towards here. This makes a sigma bond here. So 1, 2, 3, 4, 5, 6. Between 1 and 6, a new sigma bond is formed. Okay. Between 1 and 6, a new sigma bond is formed. So this is carbon number 1, 2, 3, 4, 5, 6. Between 1 and 6, a new sigma bond is formed. Between 2 and 3, a pi bond is formed. Between 4 and 5, a pi bond is formed. You have to predict the stereochemistry of these two hydrogen. One hydrogen is below, other hydrogen is above. One hydrogen is below, other hydrogen is above. So the two hydrogens are in opposite direction. Okay, so your system is a 4n plus 2 system because 6 pi electron. 4n plus 2 thermal, 4n thermal cone, 4n plus 2 thermal disrotation. So follow the ODC rule. Follow the ODC rule. Substituents are opposite disrotation, then stereochemistry will be cis to each other. That means the two hydrogen having cis stereochemistry. First hydrogen above the plane, then second hydrogen will also be above the plane. That is the stereochemistry of the two hydrogens. Okay. Okay, next question. It's number, I think, 15. Here a pi bond, here a pi bond. Condition, thermal condition. Predict the product. Predict the, here two hydrogens are there. Here one hydrogen, here one hydrogen. You have to predict the stereochemistry of these two hydrogens also. So what is the reaction here? Under thermal condition, electrocyclization. Okay, this pi electron shifted towards here. This will make a bond between this one. 1, 2, 3, 4. Between first and fourth carbon, a new sigma bond is formed. So here a 4-membered ring is formed. Okay, then here this is 1, 2, 3, 4. Between 1 and 4, a new sigma bond is formed. Between 2 and 3, there is a pi bond. You have to predict the stereochemistry of these two hydrogen. You have to predict the stereochemistry of these two hydrogen. Okay, you have to predict the stereochemistry of these two hydrogen. So first hydrogen is towards the right side. Second hydrogen is towards the left side. Okay, first hydrogen is towards the right side, second hydrogen is towards the left side. So both are in opposite direction, not in the same direction. One is towards here, other is towards there. So both are in opposite direction. So system is 4n system. 4n thermal rotation is cone. 4n thermal cone. You have to follow the ODC rule because substituents are opposite. But here rotation is cone, so OCT. If ODC, then OCT. Substituents opposite, cone rotation, they are trans to each other. The two substituents are trans to each other. That means first hydrogen is above the plane and second hydrogen is below the plane. That is the stereochemistry of the product. Okay, so that is about the stereochemistry problems. In the next lecture, we will discuss about the ring closure, opening and many other systems and further applications in electrocyclic reaction.